Okay, so yesterday we covered strings, string builders, and then at the end we also explored how to pass the commands for the main method using that option on the UI side, right? Command and arguments. Okay, and so today I will start the actual object-oriented programming concepts, and when we discuss about each and every concept, I will also show you some various examples so that you can easily apply how exactly this theory works. Okay, so we'll start with the static class. Okay, I know a few times I have discussed about the static class, but I did not mention what exactly it is. Okay, so static class is a class. Okay, so class means it contains data members and methods. Okay, every class contains methods and data members. Okay, so but when we declare a class with a static, that means you are not allowed to create any instance. That means you are not allowed to create any objects. That's why it's a static. You cannot create the objects. Okay, and also if you define a class as a static, there is no way you can inherit the static class. Okay, so that inheritance means you are trying to adapt the properties of the parent class to a
To
child
child.
class, right? So when you declare a class with a static, you cannot inherit any static class. Okay, so just remember, static means static. It is static. You are not allowed to create any objects. Okay, and you cannot, basically you cannot apply inheritance concept on the static classes. Okay, but interesting, right? So if I'm going to declare the class as a static, okay, so obviously if you want to use a class, definitely you have to create a object, then you start using it, right? You can directly use. But with the static class, since it does not allow you to create the object, okay, you can refer the methods or variables of a static class directly using the class name. Okay, so let me show you one example. Okay, also let me take okay, so let's say this is your class A. Okay, and let's say it contains a couple of variables A and B, and it contains a function called calculate. Okay, so in general, if you declare a class, okay, the only way you can use this class is by declaring a or by creating a instance of the object class, right? So you have to say, like, class A. I'm just saying like this. Okay, so basically there is a class A and you are declaring a object. Okay, that means if you want to access these variables or method of a class A, you have to use with this object. That means you can say A dot A, you can say A dot B, or you can say A dot calculate. Okay, so there is no way you can directly use the variables or methods of a class without creating the object. That is the fundamental rule of classes. Okay, but if you go with static classes, okay, static class doesn't allow you to create the object. Okay, so since you are not going to create the object, but in case if you want to refer the data members or the methods, you can directly refer using the class name. Let's say, like, if I say it's a static, right? So if you declare a class as a static, by default okay, all the variables, okay, and all the methods become static. Okay, that means you are not required to create a object. You can say in the program, what is your class name? A, right? So you can say a dot a to get the value of a. You can say a dot b to get the value of b. You can say a dot calculate. So without creating the object, by referring the class name, you are able to access the data members and methods. Okay, so let's see the example. Okay, so I have the internal class name program, okay, and one method, which is main method. So here I have declared a variable, okay, to store the value of pi. Okay, so if you see, I have used the word constant. Okay, it's a constant type of variable. Oh, sorry, man, I'm talking different one right here. Where am I? Trainings. Okay, yeah, right. Okay, so here just to try to understand. You may not be able to fully understand because there is some constructions concept here is there, but I just wanted to introduce this method or this class before I go in detail. Okay, so if you see, there is a class called college. Okay, and if you see, it's a static. I mentioned as static. Okay, and there are three static variables. Okay, so I said, like, if you declare a class as a static, by default all the data members and all the methods becomes static. Okay, so if you see, I declared a static variable name to store the name, and address, again a static, and phone number. So there are three variables are declared to static. Okay, and there is one method, okay, which is timetable, to print this values time t and time. Okay, and so basically, if you see, there are three variables, okay, and one method, college. This is called constructor, guys. Normally, constructor is having the same method name like the class name. Okay, just now it's a one method we have. Okay, and another method called timetable. Okay, so three variables and two methods. Okay, and since this class exists within the namespace, right? So I am directly trying to call. You see here in the main method, I'm trying to print the value of name, address, and phone number. But see how what I'm doing. I am directly college. College is the class name, right? College is the class name. So I have not created any instance. Okay. So if you see, I made a comment also. Access the static class member by class name itself. There is no need to create any object. So class name dot the name, class name dot the address, class name dot the phone number. Okay, and again you see, I am invoking the method timetable also. Okay, so timetable is to print a couple of values. Okay, let's see. Okay, so it printed name, address, phone, and timetable is a method, right? So method is just to print the morning. So clear, guys? Static class, static members, and static methods. Okay, so this is one concept, and one more concept is constants and read only. So constants, I think we have already discussed about this in when we were writing the programs. but I am again touching this because there is one more concept called read only. So there is some a difference between these two. That is the reason I am again bringing back this concept. So constants, okay, constants, it is the object or it's a variable in the program which normally do not change its value throughout the life cycle of the program. So once you declare a value as a constant, there is no way you can modify that value during the program execution. Okay, so just remember guys, whenever you define a constant in a class, right? Okay, and you can access this that constant value by referring the class name. It's kind of a static in nature. Okay, and so I think I can explain easily by taking one example which I shown you previously, right? Instance. Open here, constant, right? Mhm. What's happening? Okay, maybe because open this file, right? Maybe that's the reason it is not allowing. Okay, now we are good. Okay, so here what I'm trying to explain is, if you declare a constant or if you initialize a constant value in the program, so there is no way you can change the value of a constant value, right? You don't need to refer the object. By default, constant variables are static in nature. So when I say static, you don't need to create any object for that class, right? So if you see here in one of the class, I declared the constant of float type. It's a pi value. I store the pi value here in the py variable. Okay, and if you see in the main method, okay, I am directly printing the value. Okay, so program is a class name. If you see, the class name is program.py. So I am not creating any object instance to access the constant value. Okay, that is one point you need to understand. Second thing is, once you declare a constant, once you initialize a constant in the program, okay, there is no way you can modify it. If you see, I declared one more constant, okay, within the main method. Since it is within the main method, even I don't need to, say class name also. Directly I can refer the variable or the constant name. Okay, and let's see, so I have assigned a 10 value and I have printed. If I try to modify the value, Okay, see, it's already giving a warning. See, the left hand side of an assignment must be a variable, property, or indexer, because my you know the so this Visual Studio knows that the number is a constant type by looking at the definition. That's why it's saying that, hey, this is a constant value. You cannot assign, you cannot modify the value here. You can only leverage either a variable or a property or index. Okay, so once you initialize a constant value, there is no way you can change it. Okay, so if you see first, I have tried to print the value by referring the class name dot the constant. Okay, 3.14, and directly I tried to print. Why I directly use this? Because my main method is within the same class, right? So if it is within the same class, there is no need to explicitly mention the class name. Okay, and third one is, so again, second time I printed 3.14. Third one is, it's a constant value, number 10. I tried to print, it printed 10, and I tried to change the to 20, which compiler did not accept. Okay, so the difference between constant and read only. So constant is at the class level, and you can always refer the value, and you do not need any object instance. Okay, so the constants are immutable values that are known at the time of program compilation and do not change their values for the lifetime of program. Okay, but read only, the only thing is, constants are the values which are known at the time of compilation, whereas read only, the values are passed at the time of runtime during the execution time. Okay, and one more thing, the read only variables are specific to the object. Whenever you create the instance of an object, during that time the values will be initialized, and during the life cycle of the object, that value continues to be available. Okay, so the difference what I explained is, constant variables are at a whole class level. Okay, and whereas read only variable is at a object level. Probably I can easily explain you by taking one more example. Okay, so for constant we are using the keyword const, but for read only you have to use read only. Okay, read only, integer type, number equal to 5. Okay, so previously when we were using the constant pi value, we are directly accessing or directly referring the pi value by mentioning the class name dot pi, or we simply mentioned pi, print the pi value. But if you declare as a read only constant, okay, if you want to use that, you have to create the object. Okay, so for read only you have to create the object, there is no way. If you see in the main method, I have created a object for a program class object. Okay, so whenever you create an object, that time, okay, so this value will be assigned for that particular object. Okay, so here what are you doing, it's a value of 5, right? So once you create the object, okay, for this object there will be a number assigned with the value of 5. So, and one more thing we mentioned here is, one more thing you mentioned here is, if you see The read-only variables are also immutable and known at runtime. Remember, known at runtime. Runtime means once you create the object, then only you will have this value assigned for that object. So when this object creation happens, when you try to run the program. Okay, so during runtime, okay, this statement got executed, object method object, and then the value 5 assigned for that object. Okay, so remember guys, suppose let's say you are creating 5 objects for the same class, then you have 5 different uh, objects in the memory. That means you have the value 5 is available for the 5 different objects. Object 1, object 2, object 3, 4, 5. So it is at the object level. Okay, and objects gets created during the runtime. Okay, and if you try to change the value of a constant, it will give error. You see, a read-only field cannot be assigned to except a constructor or init-only setter of the type. So only I have already initialized the value when I am defining my class. Okay, you already assign a value during the class creation. So you cannot change the value of a read-only constant during execution time. Okay, so clear? Static class, constant, read-only. Any questions? I will try to club all these three, like in the static, constant, read-only, all into one, and I will show you like how you can easily differentiate.
Yeah, no, yeah, good to go.
Yep, thanks. Okay. So here I have my namespace, okay, and I have my internal class, okay. Internal class name is program, okay, and then I have my main method, okay. So if we see in the internal class, okay, I have declared a constant value of float type, pi value, okay, and I have declared a static value integer x equal to y, okay. So just if you recall what I said earlier, if you define a constant, okay, or a static at the class level, you can directly access the values by referring the class name, right? So this is one thing, and here is I have created one regular variable integer y, okay, and I have created one read only. And since I don't have any value assigned to y or z, okay, I'm using constructor to initialize the values. So constructor, just wait for 10 minutes. I will explain what is constructor also. So for now, constructor is nothing but it is a method within a class, and the constructor, the name is similar to the class name. So if the class name is A, constructor name also A. Okay. So basically constructor is a method which gets invoked whenever you create the object. By default, it gets invoked. Okay. So since I don't have any values for y and z, I am passing couple of values here, A and B, and I'm storing A value in y, B value in z. Okay. So easy. It's a one constant variable, one static variable, one integer, one read only. Okay. And since I have already initialized the constant and static value, okay, there is no need to or there is no way you can change the values. Okay. But for the regular integer and read only, I have not initialized. So I am initializing through a constructor. Okay. And if you see here now, just go one by one. I will try to help you out here to easily understand. So first thing is X, right? So X is a static variable. Okay, and since it is already defined within the same class, okay, you can directly print X value, or you can say program dot X. Okay, so I just mentioned X here, print X value. Then I said print pi value also. So pi is what? It's a constant. Again, for constant, you don't need to mention, or basically you don't create any object, so you can simply use the directly the value, or you can say program dot pi also. But since it is within the same class, I'm just directly using the value X or pi. Okay, you see, accessing the static variable without creating any instance, accessing the constant variable without creating any instance. Okay, and now I have created a couple of objects 1 and 2, and I'm passing some values. Okay, so here 345, right? Object 1, y contains 300 and z contains 45. Okay, and I'm directly printing the values using the prefix object. Okay, object dot y, object dot z. Okay, x value is 100, pi value is 3.14, and object 1, object 2. Okay, so the main thing you have to remember is static classes are not, you know, available to create the object, and whatever the methods or members available in the class, you can directly access them by referring the class name. Okay, that is one thing. And constant variables or read-only variables, they are, once you define or initialize a value, you cannot change the value. Okay, constant is at the class level, whereas read-only is at the object level. Okay, so since the constant is at the class level, you're directly accessing the value. Okay, but read-only value, which is here z, it is at the object level, and that's why you are referring with object 1 dot z, object 2 dot z. Okay, so clear guys, any questions? These three concepts. Okay, okay, so we'll
Yeah,
just
Navya.
get into, yeah, thanks. So we'll get into further a few more concepts I have to explain. Okay, so before that, just to refresh your memory, when we started in the day one class, we were talking about the object-oriented programming, where we mentioned about the data abstraction, encapsulation, inheritance, and polymorphism. These four are the important characteristics of object-oriented programming. Okay, so just to refresh your memory, abstraction is a process of hiding the implementation details and showing the users whatever is required for them to execute. Okay, so we hide all the important things. So if you remember, like I explained to you about driving a car. If you want to drive a car, you just need to know how to change the gears, how to use your clutch pedal, how to use your steering. You really do not know how the fuel burns, how it's converted to a kinetic energy, and how the movement happens, right? You do not require all those things. Okay, you only need to know how to drive. So basically, it is hiding the things which are not required for you, and only explaining you, or it will only guiding you. Okay, hey, you need only these things to take care of the car. Okay, and that is abstraction. So encapsulation is basically, since every class contains members and methods, okay, you are bundling both of them into one, so it is called encapsulation. Okay, so if you ask me, data abstraction is a theory and encapsulation is a implementation part. Okay, so I will just try to I just try to put the same slide here. If you see, to clearly explain the difference between abstraction and encapsulation. Okay, so let's say, you have a functionality registration. So for any program, suppose if you wanted to register, okay, for any program or for any social welfare activity, anything, right? Or if you want to join a college or university, first thing is you have to register yourself. Even the Gmail, you have to register yourself, right? So what happens when you try to register in the Gmail? First, it will ask you to enter your name, okay, your phone number, your address, your age, your date of birth, and all those things, right? So first you are entering the values. Then what happens? It will validate. Okay, so if you don't enter any value, it says like no, hey, it's mandatory field. You're supposed to enter like that. So it validates whatever you have entered. Okay, and then it will establish a connection to the Gmail server database. Okay, and then takes the values whatever you have entered on the UI, okay, and saves it on the database. So these three methods we use if you want to register yourself for a Gmail account. Okay, suppose let's say, okay, I have my I have already defined three methods. Okay, okay, hey guys, these are the three methods. If you want to register for a Gmail, let's use it. Okay, so at the end user, you may not know which method you have to execute first, or there is a chance that you may do a error. Instead of invoking the validate function at first, you may say get connection string at first, or you may say save user at first. So if you provide more liberty to the user, he may make some kind of mistakes. Okay, so instead of providing access to three methods, what I will do in order to avoid these mistakes, I will club these three methods into another method called register. Okay, and I will say, hey guys, you don't need to invoke all these three methods, just invoke only register method. So in the register method, I mentioned, okay, whenever the end user invokes a register method, first you do the validation, then you try to establish a connection to the database, then you save the details which are entered on the UI. So I am only giving what is required for the end user. I'm not giving more flexibility or more liberty, asking to use whatever the way you wanted to use. So this is a classic example of abstraction and encapsulation. So abstraction is in reality, it's a theory, and the way we implement is in encapsulation. Okay, so the brilliant example, one more thing what I can give is, okay, I mentioned whenever you declare a class, right? You mention private for the variables and you mention public for the methods, because you don't want the LO in the end user to mess up the data. That's why you're defining as a private. That means nobody can use it. Okay, and okay, so fair enough. You did not give access to the variables, but how do I feed in the values for those variables? That's why we have public methods. Okay, I will give you one public method, use that method and pass the values. Okay, so abstraction and encapsulation. Okay, so here one few more things called the property example. So far you are familiar or you know that class contains a data members are nothing but variables and methods. Okay, but it also contains another type. It's called properties. Okay, so it's like properties is okay as good as data variables. Okay, as good as data variables, but properties are by default it's a public. Okay, so I mentioned just a few minutes back that like we always declare data member or a variable as a private. Okay, so if we want to provide or initialize the private variables, so one thing is what you can create a public method and you can use that method in the derived classes or somewhere and pass the variables to the private public method so that the values will be assigned to the private members. Okay, but there is also another way you can assign the values for the variables, private variables, especially in the class. So that is done with using properties. So remember, guys, this in order to use these properties, okay, there is one thing called get and set methods. So get method is to assign a value for a variable. Set, sorry, get method is to retrieve the value of a variable. Set method is to assign a value to the variable. Okay, if we just try to read the definition, properties are the special type of class members that provides a flexible mechanism to read, write, or compute the value of a private field. We use the properties as they are public data members of a class, but they are actually special methods called accessors. So if you want to assign the values to the private variables, you use the property. Okay. So if you want to implement the property, you have to use the methods called accessors. Okay. And the methods are normally get and set methods. So get is to read the property, to read the variable value. Set is to assign. And if I say get and set, it is basically to read and write. Okay. So let me show you one example. Okay. So if you see here, I have one public class, it's an employee. Okay. And I have one more class program which contains the actual main method. Okay. So if you look at this class, right, it's a public class. Okay. Uh, I have declared a couple of variables in private. Okay. And since it is private, okay, so there are two ways you can assign the values. One is by invoking the method. Okay. So if you see here, I have declared couple of methods. Okay. Public int employee ID, which is the variable name here. Say I said set or get. Okay. And also one more method, again it's a public type, employee name, set or get. So what happens is I have two private variables and I have two public methods. Okay. It's employee ID and name. And in the class, I have created in another class. Okay. Since it is a public class, right? I can use that class in my internal class. So I said create the object of employee. Okay. So I created one object. Okay. And you see here, there are two private variables here, right? Two private variables. Okay. And when I say employee object dot employee ID 101 and employee object employee name equal tetra, when I execute the statements, what happens is, okay, so you are initializing the values of a private methods, private variables, but by default it is not allowed. But using the properties, using the accessors concept, I can initialize the values. So when I say initialize these values, what happens is when it executes this first line, employee ID understands, oh, okay, employee ID you're assigning 101, but employee ID is a private variable. And if I need to assign a private a value to a private variable, I should have some kind of accesses available in my class. So control goes here and it checks. Okay, I'm trying to set the value, right? So set value is here. That means it will execute this public int employee ID. Okay, and it will assign the value whatever. Okay, I am passing here, right? Here I said 101, right? So 101 value will come to here. So remember guys, you don't need to pass the any parameters here, okay? Because properties are works like, it's like a another kind of a, how you initialize the variables. Okay, you don't need to, since it is a method, you may think that you have to invoke as a method. So whenever you invoke a method, what we do like employee ID of method, right? You do like this if you want to invoke the method. But for accessors to set or get, right? You just initialize like how you initialize a public variables. If you just initialize as a public, internally it knows that employee ID is a private variable, okay? And when you try to assign the value to a private variable, by default, okay, it looks, hey, where is the method? Okay, where is the method to assign the value? Okay, here it is. It will execute this employee ID method and automatically assigns the value. Same way, if I say employee name assignment, okay, it goes with the another. You see here, right? The employee ID, employee name. So both are the private variables name. Okay. So same way I have declared my method here. It's an employee ID method. It's a employee name method. So it knows that it has to execute this method or this method based on the variable you refer. So when you assign the value, it executes the set method. If you want to print the value, it executes the get method. Okay. So if you see, if you want to assign, you are just saying that like, you are using the employee ID, which is a private variable here, right? See underscore employee ID and just say value. It's a hard coded value. It's a, it's a hard coded value. You say just value only. You see here also I said value only. And if you want to print, you have to use get method. It will return the values. Okay. So you see first you are assigning the variables. Okay. And then you are printing the values. So for printing also you see right len, I'm directly using the object dot field name, object dot field name. Okay, let's see how it executes. Okay, ID 101 and tetra. So guys, it's, I mean, we do not use frequently this, okay, but I still wanted to explain you how these concepts work, because like, when you start writing the programs in the project, right? Okay, so you try to refer various, you know, various DLL files, okay, and different class and methods which are declared by third party sources. So you'll have a lot of content, lot of code, right? Everybody has their own way of writing the programs. Okay, some people may use, some people may not use. But as a programmer, you should know how this works. Okay, so just to repeat, property is a another kind of, third, I would say third type of data member. One is the variables which you already know, another one is methods, but this is a third type of or another kind of how do you say member within a class. Okay, so basically property methods are normally used to assign or to initialize the values for a private members. Okay, so normally we create a public method, and through public method we pass the values to initialize the private variables. But by using this property, okay, so there is a concept called accessors. Accessors are kind of a special methods which are nothing but set or get. Okay, so by using the set and get, you can assign the values. Okay, so if you want to write set and get values, you have to just use the variable name. Okay, or you can say anything x or y also. Okay, but I just mentioned employee ID and employee name, and within the set value, whatever the value I'm going to get from the object reference, I'm storing it in the actual private variable. Okay, I'm storing the actual private variable. Same way I'm returning. Okay, And whatever the method name I mentioned here, right? Employee ID and employee name. So remember, like now this is underscore employee ID underscore employee name, actual value, actual variables. But I mentioned employee ID and employee name as my methods. That's why like now when I invoke it, right? I'm using employee ID, not underscore employee ID, because my intention is to invoke the set and get method. That can be done only using EMP ID property, EMP name property. Okay, guys, clear? Let me show you one more example. Okay, so here I have taken a class of student. Okay, let me show it. It's within, okay, up to this, up to this one class. Okay, and another class which is having my main method. Okay, so here I have three private variables. Okay, one is integer, one is integer is for the ID or roll number, another one is for name, another one is to store what is the pass mark. Okay, so three variables I have declared, and all three are private in nature. Okay, so now I have my get and set methods for these three fields. Okay, if you see the first one, right? Okay, so public int ID, it's a public method, it is ID type. Okay, so internally before setting the value, I am doing a comparison whether whatever the student ID entered is less than 0. Okay, so there is a condition. I cannot directly initialize the value. There is some kind of condition is there. So I'm checking the value here, whether it is 0 or not. If it is 0, I'm throwing the error. Okay. And if it is a greater than 0, okay, then I'm storing the value. Okay. This is happening here. And get method to return the ID value. Okay. And one more method, name. Here also, whatever the value which I'm getting from the object reference, if it is a null value, I'm throwing the error. Okay. If it is not a null, I'm assigning the value here. Same way to get the name, to print the name. And also one more method. Okay. That is only having get method. There is no set because I have already mentioned the set. What is the value of pass mark? 35. So there is no need to set the value again. I will only retrieve the value using get method. Okay. So remember guys, whenever you use set and get methods, okay, using the accessories or accessors, sorry, you have to use the method as a public. You see public, public, public. Okay. And there is no need to pass any parameters. Okay. So if you see, I'm not passing any parameters here. The value, whatever I'm assigning for that ID, it is by default stored in this value, in the value value. It's a value parameter. Okay. And this method name may not be required to be same as the actual private variable name. You see the actual private variable is underscore ID, but I'm using a ID. It's a different. So it's not required that like now you have to use the same, the private variable. In fact, you should not use it. Okay, because if you try to use it, it says, hey, you're trying to access the private variable outside the class, you are not allowed. Right? So the method name is should not be equal to the private variable name. Okay. And here same name, right? Underscore name is my actual variable. Okay, but I'm using name, normal name. Okay, and if the value is it's not a null, then I'm storing the value in the actual private variable. Same way I'm returning it. Okay, So now let's see. I have created an object called student. Okay. And I'm assigning student ID equal to 101. So ID, if you see, ID is a method. It's a public method. So as soon as the compiler sees this statement, right, ID, it comes to this ID method. Okay. And you have passed the value of 101. So by default, without using any parameters, it will take the value. Since you are assigning it, it will execute the set method. Okay, set. Is the value less than 0? No. Then it will not execute this if statement. It will assign the value here. Same way, you said student name, tetra. So name is a method. You see, name is a method. Okay, name is a method. Okay, since you're assigning, it will execute the set method. Okay, so you have passed tetra, which is not a null value. So it won't execute the if statement, but it will assign the value of tetra to the underscore name. Okay, and then I'm trying to execute the pass mark. Okay, so pass mark, right? So if it is, it's a print, I'm trying to print it, right? I'm not assigning, I'm just printing the value here. Okay, so it will come here. Okay, it basically returns the value 35. You see, ID, name, and pass mark. So basically, just remember that accessors are one of the ways to assign the values for a private variables. Okay, and if I wanted to use accessories, you have to use two methods, set and get. Set method is to initialize the value, get method is to retrieve the value. Okay, and always remember these methods are public in nature because that is the only way you can assign or you can invoke the methods from the another class. Okay, any questions in the properties? See guys, at very first time, if you go through, or if it may take some time to digest, because I'm trying to introduce lot many concepts. Okay, but after the class is over, try to read. Okay, I probably I will send this deck right after this class. So you try to read and try to digest the information. Okay, so you may not be able to in a position to accept everything at a go. Okay, it takes a lot of time, I can understand. Okay, but don't get scary. Okay, it's the oops are like it may take some time to understand. Okay, to absorb, but once you are comfortable, it's a cakewalk for you. Yes, at one point of time also I'm also like you. Okay, so the only way is like
Yeah,
you
no.
read more and more, practice more and more. That way you will be very much familiar. Okay, okay, so now you are clear. Okay, so now you see that like using accessors, you have to write a set of code. Okay, you have to write the public methods, and you have to use the methods set and get, right? But
Yes, yeah, no.
okay, but with the recent versions of C hash, okay, there is a concept of called auto implemented properties, which means internally compiler automatically writes the code for you. You don't need to write the entire code. Okay, so how it works is auto property. Okay, so here, so previously we were we were writing the methods, right? We were writing the methods using set and get. Okay, but here uh, I have a class. Okay, and I have four different variables: int, ID, age, name, and address. Okay, I just mentioned get and set within the brackets. I did not write the end-to-end code. Previously we were writing big code to get and set, right? But I just say get and set. That's it. Okay, so four variables. Okay, and just directly use get and set. And in the internal class, I have created a object employee. Okay, and you see this first four. I am directly using the variable name ID, age, name, and address. Okay, and I'm initializing the values. Okay, man, my age is not this much, man. Okay, so I'm directly initializing the values. So what happens is I don't have any explicitly mentioned properties, but I have initialized get and set. So when I initialize like this, right, by default, by default, the values will be assigned. Okay, this is the new concept introduced in the later versions of C hash. So don't need to write everything, just say get and set, get and set. Okay, same way if you want to print, same thing, object dot the variable name. Okay, I mean, so just try to digest this information. Okay, and anyway, like no, when we write more programs, right, you will automatically be familiar. Okay, and one more thing is, okay, there is one thing, it's like kind of interview question here. Okay, so we have so many classes here, right, in the .NET, so many classes we use, right? So we have a lot of like parent classes and child classes. We use inheritance to derive more number of classes. But in this hierarchy, right, at the top level, at the top level, okay, it's at a parent level, that is called superclass. That superclass name is object. Don't get confused. Object is an instance of a class, but here the class name itself object. The super class or the high level parent class in .NET is object class. Okay, the name of the class is object. Okay, so since all our other classes are inherited from this super class, which is object, okay, this object superclass contains a method called toString. This toString. Okay. So since this toString method is available on the superclass, which is object, okay, and all our other classes are derived from the object class, right? So since you're deriving, you're inheriting automatically. You inherit the methods which are available in the object class. So one of the method is toString. So this toString is used to mention your class, where exactly, basically who am I. Basically that's what it gives. When you say toString, it says who am I. Let me show you. Okay, so you see here one public class, it just contains a couple of variables. Okay, and since I have declared as a public, right, I mean by default we are supposed to declare private, but just to make my life easier, I just mentioned as public. It's an example only. Okay, and here I have created an EMP object. Okay, and I'm assigning the values first name and last name. Okay, and I said write a len toString. Okay, let's see what's going to give. So what I said toString is gives basically who am I, right? Where exactly I am. Okay, let's see what it gives. It has given I am under toString example. Okay, and my class name is employee. Okay, you see, you have this EMP is a object of employee, right? So it said, okay, you belongs to employee class. Okay, and it goes one level up, and this employee is this employee class is under toString example namespace. So it also gives the namespace also. Okay, hey, you are part of toString example namespace, and your class name is employee. So this is the the usage of toString. But but it doesn't make sense, like, because it says toString, which I feel that it is used to convert a string. That's what I could sense by reading the toString method. Okay, but actually in reality it is giving which class you belongs to, which name class you belongs to, right? So that is the reason actually most of the people, when they write their code, okay, they override this function. Okay, they override this function. So guys, do you remember, like, now we were discussing about method overloading and method overriding in the day one class? Okay, not sure how many can remember that. Okay, but let me show you. Maybe you will be able to recall once I give you the example. Okay, so here namespace is toString override, and I have created one public class which is employee. Okay, again I am just, like, accepting couple of names, first name and last name. Okay, you see the toString. So that the toString belongs to the super class, which is object method. Okay, object class method. But I don't want to use the toString. The toString is just giving the class name or the namespace I belongs to. But in reality, I have to do different things with the string, toString. So what I'm doing is here, instead of leveraging the actual toString method to print the class name or namespace, I said override. Let's override this method. I don't want to print that, that who are my stuff. I wanted to do something else. So you say override. You are overriding whatever the method defined in the object class. Okay, and you are writing your own logic for that particular method. So you are overriding the system defined method with your own method. It's called override. So now, since you have used a override toString, it will execute this method. It will not go to the super class and picks up what is there in that actual method. You are overriding in the derived class. So it will pick up this one. So if you see, I have defined the employee object, and I have initialized the employee name, first name and last name, and I am trying to print it. So when I say toString, this method will be invoked here, toString. It will concatenate the first name, comma, and last name. Okay, so tetra, comma, computing. In the previous example, it was giving you the namespace dot the class name. But since you have overridden in your derived class to concatenate first name and last name, okay, it is giving you the output which you are expected in this override method. So clear, guys? How override works? It is basically, it's a method overriding. Okay, so you are overriding the actual logic which is defined in the parent class. Okay, so since it is a derived class, you have that ability to do that by using override method. Okay, clear? Any questions on this toString method and how to override? Okay, okay, so there is one more concept called, just a concept, like, just for your understanding, boxing and unboxing. Okay, so boxing means if you are assigning a value, a standalone value to a object type, it is called boxing. If you see here, right, I have a standalone variable x of integer type which holds value of 10. Okay, and if my object y, okay, so there is an object y, so it is derived from another class. Let's say that the class contains only to accept one value, which is integer type. That means you can pass the integer variable to a object y, because object y is from another class that is also capable to hold only integer value. Let's say that means you can pass the integer value to the object. Okay, so you're passing a standalone variable value to a object. It is called boxing. And if you do other way around, right? If you are initializing a object variable, object reference to a standalone variable, it is called unboxing. So here, if you remember, if you recall my 2 days back class, I was discussing about stack memory and heap memory. So stack memory is to store the standalone values. Heap memory is for objects and reference data types. So when you do this, like when you are trying to move the values from standalone to reference object and vice versa, it always involves dealing with two memories, stack memory and heap memory. Okay, so that is the reason actually generally people try to avoid using this boxing and unboxing, because it's a time consuming, it's a overhead for the compiler to refer to different memory locations and to assign or pass the values. Okay, just a concept. Just remember, boxing is to assign a standalone variable value to a object. Unboxing is to assign a object reference or object value to a standalone variable. Okay. So with this, like I whatever I have extra day, I have published it, right? So I will end up this deck. Okay. A few things I already covered. Okay. So, but I since they come under object-oriented programming, I just clubbed that slides here also. Okay. Guys, are we okay to continue for another 5-10 minutes, or is it too much of theory today?
Anything would be fine, Anna.
Fine. Okay. I mean, it's fine. And as long as you are able to digest, I'm fine. Okay. So let's take another 5-10 minutes. I'll just to quickly wrap up a few slides. Okay. So object-oriented programming, right? So you by this time now, OOPS programming always works with the objects. Everything you refer, it's called object, object, object. Okay. In the modular programming, you always say like functions or methods. Okay. But in the OOPS, everything is in the terms of objects. Okay. So with the objects, right, by using the objects, right, we can achieve these 4 different things: reusability, extendability, maintainability, and simplicity. Okay. And here right here I have mentioned about the 4 important properties, or the 4 important concepts of OOPS: abstraction, encapsulation, polymorphism, interface. Okay. So first thing, if we see reusability is done because we define the class once and you try to refer that class n number of times with the help of objects. So declare the class once. Okay. Define the object n number of times, how many times you wanted to use. It's a reusability. Okay. And second thing is extensibility. So right, inheritance is the concept we use to inherit the methods or variables of a parent class to the child class or to the derived class. Okay, so inheritance is one of the main way you can make this extensibility possible. Aggregation and composition probably we can take it later, but right now focus on only on the inheritance. And third one is simplicity. Okay, so data abstraction, which is hiding unnecessary things from the end user and only give whatever is required. Encapsulation is basically it's a practical implementation of the abstraction. And polymorphism, it's like the classic example what we use polymorphism, it's a moon. Every day it gets changed, but always moon is in with one object only, but it always gets changed every day. So that means you have to use if you remember, like I explained about method overloading. You use the same method, but you pass different variables, different type of variables. So since the method name is same but the parameters are different, it is called method overloading. You are using the same method name by passing different variables. It could be integer or float or character. That's called polymorphism. Okay, so that is method overloading. And just a few minutes back I mentioned about overriding also. Okay, you are overriding the toString method, okay, by using the override keyword in your derived class. So when we say polymorphism, two things, guys. One is method overloading, another one is method overriding. So overriding already I explained using the toString method, and I can explain overloading in upcoming slides. Okay, so when you combine all these three, right, the reusability, extensibility, and simplicity, you achieve the maintainability. That means you make your program very easy to maintain, very easy to write, very easy to read, very easy to analyze. Okay, so that's what I just tried to explain here. And here also, you know about by this time what is abstraction, encapsulation. Okay, so as I mentioned, just read this last statement. Abstraction and encapsulation are related to each other. We can say that abstraction is a logical thinking, whereas encapsulation is the physical implementation. So one is theory, one is practical. Okay, so I think this also I covered you in my previous slides. Okay, so here this also I explained inheritance. Basically, it's a, if you want to use the existing functionality of a previous class, okay, you have to use the inheritance concept. So here two things comes here. It's a parent class or base class or super class, and you're trying to use the methods or variables of those parent class. Okay, you say inherit, and wherever you're trying to use, that is called a child class or derived class. Okay, remember these three words: parent, child, base class, derived class, super class, subclass. Okay, so normally I use parent and child. That's the easy way to remember. Okay, but some people use like base class and derived class. Okay, and polymorphism, as I mentioned, it is the same method, but your purpose is different. Okay, so there are two types of polymorphism: static polymorphism or dynamic polymorphism. So static polymorphism means whenever you invoke a method, okay, at the time of compilation time, it knows that what method it has to invoke. It is called compile time polymorphism. Okay, so maybe just now for time now you remember. Okay, or probably let me take one, Excel and will explain you. So what I'm saying is easier. Compile time, okay, and runtime. You can also say early binding or late binding. Okay, and what is it? Static and dynamic. Okay, so all are same, guys. Static polymorphism or dynamic polymorphism. So all three refers to same. Okay, so if you see, static polymorphism is achieved by function overloading. Okay, this is function overloading, and dynamic polymorphism is achieved by using function overriding. Okay, so now you know we try to use this toString, right? ToString method. We were overriding ToString method in previous examples. So you are overriding. Overriding means when I say compile time, right? Okay, when you try to compile, that time only it knows which method to invoke. If it knows during the compile time, it is called early binding or static polymorphism. But if it knows only during the execution time, when you actually run the program, it is called dynamic polymorphism or late binding. Okay, so toString, it's a override, because we have, if you remember, we used the word override, right? That means when you invoke the toString method, during the compilation time, it do not know that it is going to execute the overridden method. It only knows when actually during the runtime execution. So function overriding belongs to the dynamic polymorphism or runtime or late binding. Okay. So only during the runtime, it knows that which toString method it has to execute. Okay. And whereas function overloading, okay, during the compile time only, okay. So if you remember, I don't know how many people you can recall, function overloading is basically, suppose, let's say add. Okay, I'm adding two integer values. Okay, and let's say add, I'm using two float variables. So here if you see, my function name is same, but the parameters are different. So if you have these two similar methods within the same class, okay, within your class, okay, suppose when I say add 5 comma 5, okay, so when I say add 5 comma 5, when it is going to compile, my compiler knows that, okay, for add method you guys are passing two integer values, so then I need to invoke this method. When I say add 1.5 or some value here, so here instead of integers I'm using float values. So when I when I say this one, my compiler knows that I have to invoke this method because this is the one which contains the float variables. So this is called function overloading, the same function name, but by passing different parameters, you are overloading the each other function. So this is already available for the compiler during the compile time itself. But whereas overriding, it will not know which function to execute during the compile time. Only it will be done during the execution time. That is called runtime polymorphism or the late binding. So remember guys, binding means from the main method, okay, you're trying to bind the different method. Here it is add. So from main method, you're trying to bind the another method. So this binding, that's why it's called binding. You're trying to bind add method with the main. That's why it's called binding, early binding or late binding. Because see guys, like when program is trying to execute, right, it has to know the details of this methods, add method or toString method. Okay, so this add method is already available in my code, so it can readily easily accept this add method, okay, and bind it and start executing. But in the case of overriding, this toString, right, so we have toString method in our class and it's also there in the super class. So it's an ambiguity for the compiler to know which method to execute. That's why it waits for the execution time. During the execution, it understands, okay, let me hold on, I see two methods here. Okay, let me execute this particular override command because that's what we're trying to achieve here. Okay, so it's a very important thing, like you try to remember these words: static and dynamic polymorphism, compile time and runtime, early binding or late binding. Early means compile time, late means runtime. Okay, I think I will stop it here because I'm going to explain you about the access modifiers, which will be way too much if I explain today. We can cover this one tomorrow's class. But any questions, guys? Like today's topics, we discussed about constant, read only, properties, auto properties, toString overriding. Okay, and we just revisited OOPS concepts. So any questions so far? What I will do, I will publish this, okay, for you, so you can just go through this. And I think it should be there in the previous deck, right? 1 second. If it is there, I don't need to. Okay, it's already there actually. So static class is there, constants, variables are there. Okay, and also properties are there. Okay, so I think I don't need to share this. Just go through this and try to familiar with these concepts. Okay, so any questions before we wrap up for the day? All good, or you are feeling too much heavy concepts today?
All good, Venu.
Okay, great. Akhil and Krishna, how do you feel?
Yeah, no.
Okay, guys, see, ask me if you have any questions. Okay, any question is fine. There is nothing called silly question or tough question.
Yeah,
Okay,
definitely.
okay, so you're trying to learn and be open-minded.
Yes, yeah.
Okay, yeah. So with that, we'll wind up for the day. So Krishna Reddy, you may want to stop the recording. Okay, so all right, guys, talk to you tomorrow same time, and thank you very
Yeah,
much.
no. I'll inform
Okay.
him to stop it. Yeah, okay.
Okay.
Thank you very
Yeah.
much. Yeah.
Thank you.
Yeah, bye.
Bye. Have a rest of the day. Rest of the
Yeah,
good day.
you too.
Bye.
Take care. Bye.